Hello everyone. In this session we are going to learn about network analysis in GIS. In this video, the concept of network and network analysis is discussed with a special reference to the network analyst tool in ArcGIS software, which encompasses 6 main types of network analysis operations, otherwise called as solvers, such as route, closest facility, service area, OD cost matrix, vehicle allocation problem, and location allocation. To start with, a network refers to a structure representing a group of objects or people and relationships between them. A network structure consists of nodes and edges. Here, nodes represent objects that we are going to analyze, while edges represent the relationships between those objects. For example, if we are studying a social relationship between Facebook users, nodes are target users and edges are relationships such as friendships between users or group members. In our day-to-day life, almost everyone has needed a type of network analysis. For example, considering the questions such as what is the shortest route to a hospital, where should we build a shop for good business, how can we optimize a vehicle delivery fleet, etc. Network analysis is an operation in GIS which analyzes the datasets of geographic network or real-world network. Network analysis examines the properties of natural and man-made network in order to understand the behavior of flows within and around such networks, and locational analysis. Any network consists of a set of connected vertices and edges. Network analysis is basically a set of connected lines. These lines may represent railways, streams, roads, water lines, pipelines, etc. that normally need to be analyzed as a network. It can be either direct and indirect or planned and unplanned. Network analyzes the movement of people, connectivity and accessibility of railways, roads, pipelines and telecommunications, etc. Any type of network is connected by vertices and edges. GIS networks are algorithms of interconnected lines termed as edges and intersections termed as junctions or nodes. It works as a path for movement of people, goods and services. The object navigating the network follows the edges, and junctions appear when at least two edges intersect. Junctions and edges can have certain attributes affixed to them that increases the cost of traveling the network, known as impedance. For example, a road network can have speed limits attached to the edges, and the junction can prevent left or right turns. Laurini and Thomson identified the following types of networks, such as oriented and unoriented network types with or without loops. Rivers flow the direction of downfield. It is the best example of an oriented network. The road connectivity can be either oriented or unoriented, that is, one way or two way, and usually roads contain loops. Trains usually travel in both directions between stations. One track, the railway network, with smaller lines represented as unoriented. Somewhere else in the network, lines designated for travel in one direction only for the safety purpose. Two-track networks represented by a pair of oriented links in a network can be either an oriented or unoriented network. The direction of network or their link can have other properties that represent a cost of moving along that link. For example, nodes can have properties that might encourage or discourage travel in that direction. Now, let's move on to the common network analysis operations that can be employed in ArcGIS software. In ArcGIS, the Network Analyst extension allows us to solve common network problems such as finding the best route across a city, find the closest emergency vehicle or facility, identifying a service area around a location, servicing a set of orders with a fleet of vehicles, or choosing the best facilities to open or close. First one is the route solver. Network analyst can find the best way to get from one location to another or to visit several locations. The locations can be specified interactively by placing points on the screen, entering an address, or using points in an existing feature class or feature layers. If we have more than 2 spots to visit, the best route can be determined for the order of locations as specified by the user. Alternatively, network analyst can determine the best sequence to visit these locations, which is known as solving the traveling salesman problem. In different situations, the term best route can mean different things. The best route can be quickest, shortest, or most scenic route depending on the impedance chosen. If the impedance is the time, then the best route is the quickest route. Hence, the best route can be defined as the route that has the lowest impedance, where the impedance is chosen by the user. Next one is the closest facility solver, finding the closest hospital to an accident, the closest police cars to a crime scene, and the closest store to a customer's address are all examples of closest facility problems. When finding closest facilities, we can specify how many to find and whether the directions of travel is toward or away from them. Once we have found the closest facilities, we can display the best route to or from them, return the travel cost for each route, and display directions to each facility. Additionally, we can specify an impedance cutoff beyond which network analysts should not search for a facility. For instance, we can set up a closest facility problem to search for hospitals within 15 minutes drive time of the site of an accident. Any hospitals that take longer than 15 minutes to reach will not be included in the result. The next one is the service areas. With network analyst, we can find service areas around any location on a network. A network service area is a region that encompasses all accessible streets, that is, streets that lie within a specified impedance. Accessibility refers to how easy it is to go to a site. In network analyst, accessibility can be measured in terms of travel time, distance, or any other impedance on the network. For instance, the 10-minute service area for a facility includes all the streets that can be reached within 10 minutes from that facility. Next important operation in network analyst is the OD cost matrix, that is origin destination cost matrix. With network analyst, we can create an OD cost matrix from multiple origins to multiple destinations. An OD cost matrix is a table that contains the network impedance from each origin to each destination. Additionally, it ranks the destinations that each origin connects to in ascending order based on the minimum network impedance required to travel from that origin to each destination. The best network path is discovered for each origin destination pair, and the cost is stored in the attribute table of the output lines. Next one is the vehicle routing problem. A dispatcher managing a fleet of vehicles is often required to make decisions about vehicle routing. One such decision involves how to best assign a group of customers to fleet of vehicles and to sequence and schedule their visits. The objectives in solving such vehicle routing problems, otherwise called as VRP, are to provide a high level of customer service by honoring any time windows while keeping the overall operating and investment cost for each route as low as possible. The constraints are to complete the routes with available resources and within the time limits imposed by driver work shifts, driving speeds, and customer commitments. The network analyst provides a vehicle routing problem solver that can be used to determine solutions for such complex fleet management tasks. Considering an example of delivering goods to grocery stores from a central warehouse location. A fleet of 3 trucks is available at the warehouse. The warehouse operates only within a certain time window from 8 am to 5 pm, during which all trucks must return back to the warehouse. Each truck has a capacity of 15,000 pounds, which limits the amount of goods it can carry. Each store has a demand for a specific amount of goods that needs to be delivered, and each store has time windows that confine when deliveries should be made. Furthermore, the driver can work only 8 hours per day, requires a break for lunch, and is paid for the amount spent on driving and servicing the stores. The goal is to come up with itinerary for each driver such that the deliveries can be made while honoring all the service requirements and minimizing the total time spent on a particular route by the driver. And in the image shown here, it shows 3 routes obtained by solving the above vehicle routing problem. The last one is the location allocation solver. It helps us to choose which facilities from a set of facilities to operate based on their potential interaction with demand points. It can help us answer questions like, given a set of existing fire stations, which site for a new fire station would provide the best response time for the community? Or, if a retail company has to downsize, Which stores should it close to maintain the most overall demand? Or where should a factory be built to minimize the distance to distribution centers? In these examples, facilities would represent the fire stations, retail stores, and factories, and demand points would be buildings, customers, and distribution centers. The map here shows the results of location allocation analysis meant to determine which fire stations are redundant. The information provided to the solver includes an array of fire stations, street midpoints, and a maximum allowable response time. The response time is the time it takes firefighters to reach a given location. The location allocation solver determined that the fire department can close several fire stations and still maintain a 3-minute response time. Now, let's discuss some case studies which utilize network analysis in GIS. The first one is GIS based network analysis for road network of the Greater Cairo area. The main purpose of this paper is to provide an enhanced network analysis that uses the capabilities of GIS to identify the best route from the location of an incident for any healthcare service providers in the Greater Cairo metropolitan area. These figures shows the base map of Greater Cairo, which is extracted from the OSM in QGIS, and the flowchart of the methodology employed for this paper. In this research, 6 stages of the processes have been applied, beginning with the collecting and preparing the data that will be used in the analysis, like the study area base map, road network data, healthcare service provider data, and historical traffic data. Then georeferencing the base map of the study area. Following this is the creation of a geodatabase that will store the prepared data. Then building both the network topology and the network dataset. Finally, the network analysis process has been applied to the road network of the Greater Cairo region. In this paper, the authors provide analysis and comparison of the results of the network analysis using 2 different methods. To navigate from one location to another, either the route with the least length, that is the shortest route, will be selected, or the route with the least travel time, or the best route will be selected depending on the impedance factor chosen. Here, the first image shows the result of the shortest route analysis, and the second image shows its graphical representation. In this analysis, the road length has been chosen as the impedance factor, the starting time of traveling to be 3 p.m., which is the evening rush hour traffic on the road network in the Greater Cairo area. And this is followed by best route analysis, and these pictures shows the result. In this analysis, the road's travel time is chosen as the impedance factor, and this analysis was performed at the same time and over the 7 days of the week as the shortest route analysis. The obtained results can be represented graphically as shown here. The results obtained in this paper showed that the best route travel time is much better than the shortest route travel time by 22%. In emergency situations, it is essential to reach the location of an incident as fast as possible to rescue people's life. So, based on the obtained results, this paper recommended that the GIS best route algorithm is better than the shortest route algorithm in emergency situations, especially in a crowded city like Great Cairo region. Moving on to the second case study, GIS based application for emergency preparedness and management accelerating response system through GIS. This application is mainly intended for crime and other related departments to cater the aspect of emergency response system. This application intends to serve the purpose of reducing crime and providing immediate response to victims in an accident by police and all crime related departments. This desktop application is broadly classified into 3 sections. One is to provide ground truth locality of incident, second is to provide efficient response, and third is to perform crime related analysis. This image shows the primary level data used for this application. Geodatabase for point location of hospitals, fire stations and police stations, and road network is made along with other associated attributes. All database including previously occurred incidents along with other attributes are also prepared. The road network is used to create network dataset, which is used to perform network analysis like generating service areas, finding optimal route, and others using Network Analyst extension for ArcGIS. The Network Analyst extension also has a tool called Update Live Traffic for integrating real-time traffic information, which is provided by Navtech India, which is utilized here to make the work easy for the police to reach the incident location. The location of an incident can be known either by location-based services provided by the mobile service providers or through geocoding. A detailed transportation network is also maintained, which is integrated with real-time traffic data provided by Navtech for India. After knowing the location of incident, the nearest patrolling vans are immediately notified as they are being continuously tracked using third-party software, which extracts the location of the user at regular intervals, which could be exported to ArcMap and represented as point feature layer. Once immediate response is being sent to the incident location, buffer analysis is performed and nearest police station, fire station, hospitals are highlighted on the map, followed by various analysis which would include finding shortest route using OD cost matrix, network analysis, proximity analysis, etc. This application would use full capability of GIS and would work as a good decision making tool during the delicate hour of an emergency where right decision matters greatly. The application is mainly intended for crime or related departments to assist them in making a quick response to an incident. The aim is to show how GIS capabilities can be leveraged by them in making quick and accurate decisions at all times. It would also help in analyzing the crimes and generating hotspots of those crimes along with other associated factors.